Welcome to Tennessee's at-home learning series for math. Today's lesson is for all our 7th graders out there, though all children are welcome to tune in. This lesson is the 13th in our series. My name is Kayla Anderson, and I'm an 8th grade math teacher at Rocky Fork Middle School in the Rutherford County School District. I'm so excited to be your teacher for this lesson. Welcome to my virtual classroom. If you haven't seen any of our previous lessons, you can find them at www.tn.gov/education. That's also where you can find the optional student packet. If you haven't seen any of our previous lessons, you can still tune in today, but it may be more fun if you go back and watch the other lessons first, since we'll be discussing material that we reviewed previously. Today we're going to be discussing using the constant of proportionality to write equations and then use them to solve problems. Before we get started, to participate fully in today's lesson, you will need paper, pencil, a surface to write on, and you may want the student packet at the website that I mentioned before. Okay, let's begin. Have you ever run a race before? It can be quite tiring and fun at the same time. Well, Jamal is about to run a very big race and needs our help. Jamal can run 1 mile in 5 500 minutes. If Jamal maintains this pace during a 5-kilometer or 5K race, he expects to break the course record of 15 2500 minutes. Is Jamal's expectation reasonable? Explain. Let's get started. What if we let m equal the number of miles in a 5K race? Do you remember how many kilometers are in a mile? That's it. There are 1 6/10 kilometers in 1 mile. What have we already worked with this week that could help us solve this problem? You're right, proportions. So if we know that 1 mile is 1 6/10 kilometers, then we can figure out m miles in 5 kilometers. So there's our proportion. We can solve this equation for m. How can we isolate this variable m? Make sure you can see that. How can we isolate that variable? Well, remember that when we solve equations, we use inverse operations. Since we're dividing by 5, m is being divided by 5, we can eliminate the 5 in the denominator by doing the inverse of division, which is multiplication. Let's multiply both sides by 5. Okay, once we've done our multiplication here, we get 5 over 1 6/10 is equal to m. 5 divided by 1 6/10 is 3 and 125 thousandths. So what does this mean? Well, it means that there are 3 and 125 hundredths miles in a 5K race. 3 125 hundredths miles in a 5K race. Well, the problem says that Jamal can run 1 mile in 5 500 minutes. That's a really fast pace. If the total race is 3 and 125 hundredths miles long, we need to figure out if Jamal can break the course record of 15 and 25 hundredths minutes. Let's set up a proportion. So he can run 1 mile in 5 500 minutes. Okay, so we know that Jamal can run 1 mile in 5 500 minutes, and he wants to break the course record of 15 and 2500 minutes. So we need to know x miles here. We need to solve and find x miles. So let's set up a proportion. So how can we solve this for x? Right, we're going to use inverse operations for division again. So what's the inverse of dividing by 15 and 25 hundredths? Right, multiplication. So let's multiply both sides by 15 and 25 hundredths. Okay, that gives us 15 and 25 hundredths over 5 500 is equal to x. Doing our division, 15 and 25 hundredths divided by 5 and 5 hundredths gives us 3 and 2 hundredths. So what does that 3 and 2 hundredths mean in the context of the problem? You are correct. At Jamal's pace, he can run 3 and 2 hundredths miles in 15 and 25 hundredths minutes. Well, that 3 and 2 hundredths miles is just short of the 3 and 125 hundredths race, so he's not going to break the course record at that pace. So we just used the constant of proportionality to help us solve a real-world problem to help Jamal. Let's do some more problems to continue learning about the constant of proportionality. The constant of proportionality is the constant multiple that relates proportional quantities x and y. It is the value of the ratio y over x and is represented by k in the equation y equals k times x. That's a lot of variables. Let's do another example of how to calculate the constant of proportionality and how to write an equation. Later on, we will use it in order to solve problems. So here's our first question. Oops, sorry. Here it is. A sponge is an example of a filter feeder. It takes in food by filtering water through its body. The sponge maintains a constant flow of water through its body. What is the constant of proportionality if the sponge passes 8 liters in 10 hours and 12 liters in 15 hours? It may be helpful to make a table in order to organize the information. So here's my table. You might want to go ahead and copy this table down because we're going to continue using it throughout the problem. I'll pause so you can do that now. From the problem, the sponge can pass 8 liters of water in 10 hours. So let's go ahead and add this information to the table. Next, from the problem, the sponge passes 12 liters in 15 hours. Let's go ahead and add that as well. Now we can start calculating the constant of proportionality. We are going to place the liters in the numerators of the ratio and the corresponding time in the denominator of the ratio. So here, liters over hours. So we're going to have two ratios using our information in the table here. 8 liters in 10 hours, 12 liters in 15 hours. Okay, so do you know what 8/10 is equal to? Well, dividing the numerator and the denominator by 2, 8/10 is equal to 4/5. How about 12/15? What's that equal to? I hope you said that by dividing 12 and 15 by 3, 12/15 is equal to 4/5 as well. Since both of these ratios are equal to 4/5, the relationship is a proportional relationship. Remember that we discussed in a previous lesson that it's a proportional relationship if both of these unit rates or if both of these ratios are equivalent to one another, and they are, so it is a proportional relationship. And the constant of proportionality is that 4/5. And remember that 4/5 is also equivalent to 8/10. So there's our constant of proportionality. We're going to finish this problem by putting the constant of proportionality in our table and writing an equation. So we know that 4/5, 8/10 is equal to 4/5, which is equal to 8/10, and 12/15 is equal to 4/5, which is equal to 8/10. So when we write our equation using this constant of proportionality, it's going to be y equals 8/10 x, or we could write it as y equals 4/5 x. And it doesn't matter which of those representations you prefer. Okay, and remember that x in this is the number of liters that have been filtered and y is the amount of time. Okay, so now that we know that constant of proportionality and we know our equation, let's look at some examples of how we can use it to solve problems. Okay, So 1 inch is equal to 2 5400 centimeters. So how many centimeters are in an 18-inch ruler? Well, first we need to find the constant of proportionality in order to be able to write our equation. Lucky for us, this problem already tells us the constant of proportionality. For every 1 inch, it's 2 5400 centimeters. So that means that 2 5400 is our constant of proportionality. Now we need to write our equation. Remember that the equation is y equals kx, and k is the constant of proportionality. So y equals 2 5400 x. Remember here also that y is the number of centimeters and that x is the number of inches. So now that we have our equation, the problem asks us how many centimeters is an 18-inch ruler. So using the equation, we can solve in order to figure out the number of centimeters. So y equals 2 5400. Again, we just said that x is the number of inches and it's an 18-inch ruler. So we're going to replace x with 18 or substitute 18 for x. Doing that multiplication, get 45 7200. So there are 45 7200 centimeters in an 18-inch ruler. You are really starting to get the hang of this, guys. Let's keep going, and I think you're going to be able to start trying parts on your own, and then eventually you'll be able to do the whole problem on your own. So let's look at another example. A florist sells a dozen roses for $35.40. She sells individual roses for the same unit cost. Write an equation to represent the relationship between the number of roses, x, and the total cost of the roses, y. How much would 18 roses cost? Go ahead and work with me on this one. First, we need to calculate how much each rose costs, and that cost for each rose is going to be our constant of proportionality. The problem says that for a dozen roses, it costs $35.40. So how many roses are in a dozen? Right, there are 12. So our ratio is going to be $35.40 for 12 roses, because remember that 12 roses are in one dozen. Okay, so we now need to calculate the constant of proportionality so that we can write our equation. So in order to find our constant of proportionality, we're going to need 1 on the bottom here, 1 rows. So in order to set up our constant of proportionality where we have 1 rows in the denominator, we're going to need to divide by 12. Because 12 divided by 12 will give us the 1 rows. Well, if we divide by 12 in the denominator, we're also going to need to divide by 12 in the numerator so that we create an equivalent ratio. Well, $35.40 divided by 12 is $2.95. So from this, we can tell that it's going to cost $2.95 per rose, and that is our constant of proportionality. The problem asks us to write an equation to represent the relationship between the number of roses, which is x, and the total cost of those roses, which is y. So if we're going to write our equation, y equals kx, k being the constant of proportionality, and that is $2.95 times x, and remember x is the number of roses. So now that we found the constant of proportionality and wrote the equation, we can solve the problem. The problem asks for a price of 18 roses. Since x is the number of roses, and we're talking about 18 roses, I'm going to substitute 18 in place of x. So 18 roses replaces x. Doing the multiplication of $2.95 per rose, 18 roses, I'm going to find out that it costs $53.10. So using the constant of proportionality and the equation, we're able to calculate that it would cost $53.10 in order to purchase 18 roses. Okay, here's another example. The manager of a concession stand estimates that she needs 3 hot dogs for every 5 people who attend a baseball game. If 1,200 people attend the game, how many hot dogs should the manager order? Well, from our previous examples, what's going to be your first step? Right, you need to calculate the constant of proportionality. Why do we need that constant of proportionality? Right, again, we need the constant of proportionality so that we can write an equation and then use the equation to solve the problem. The problem tells us that the manager needs 3 hot dogs for every 5 people. Well, that's a ratio. Go ahead and write the ratio of hot dogs to people and then check with mine. Okay, your ratio should be 3 hot dogs for every 5 people. All right, good job. So can we reduce that fraction? No. What can we do? Right, we could change it into a decimal. It is 6/10, or we can just leave it the way it is. Remember in our previous example that we use the constant of proportionality to form an equation, and then we're able to use the equation to solve problems. Also recall that the equation is going to be y equals kx, and k is the constant of proportionality. So what is our constant of proportionality for this problem? Right, it's the 3/5 or 6/10 that we calculated just a minute ago. This 3 hot dogs for every 5 people, the 3/5 is our constant of proportionality. Now that you know that, I'm going to pause while you write an equation using the constant of proportionality, and then we'll check together. Okay, so does your equation look like this? Great. Remember that it could also look like this. Oops. Either representation is fine. What is x representing in this equation? What about y? So x is the number of people who will attend the baseball game, and y is representing the number of hot dogs that will need to be ordered. It's really important to know what our variables mean. So the last part of the problem is using this equation that we just created in order to figure out how many hot dogs the manager needs to order if 1,200 people attend the game. Which of those variables did we say represents the number of people in this equation? Right, X does. So go ahead and calculate how many hot dogs the manager needs. Take your time. I'll pause for a second while you work that out, and then we'll check together. Okay, so we're using this equation y equals 3/5 x, where 3/5 is our constant of proportionality, and x is the number of people that are attending. So I'm going to substitute 1,200 in place of x because there are 1,200 people attending the game. Once we've simplified and done our multiplication, y equals 720. So if 1,200 people attend, the manager needs 720 hot dogs. Did you get that? Awesome. So you are going to do this next one all by yourself. A half dozen cupcakes cost $15. What constant of proportionality relates the number of cupcakes and the cost? Write an equation that shows the relationship. How much would it cost for 2 dozen cupcakes? I'm going to pause while you begin working on that one on your own. Once you've had a chance to do this one, then we'll work through it together. Okay, so what would you do first? Right, you would find the constant of proportionality. So the constant of proportionality is going to be a price per cupcake. The problem says that it's $15 per half dozen. How many cupcakes are in a half of a dozen? Right, there are 6 of them. So was your ratio $15 for 6 cupcakes? Awesome. So were you able to reduce that ratio? Yes, you are able to reduce that ratio. Once we've divided by 6 here to reduce this ratio, we figure out that it is $2.50 for 1 cupcake. Did you get that? Great, let's keep going. So if it costs $2.50 per cupcake, then what is your equation going to look like using the constant of proportionality? I'll pause for you to make sure that you have that equation. Make sure that you explain what your variables represent. Okay, so I wrote the equation y equals $2.50 x. Because if we started with this ratio, reduced it here, this $2.50 for 1 cupcake is our constant of proportionality, which is k in this equation. So what did your variables represent? What does x represent? What does y represent? Right, x is the number of cupcakes purchased, and y is the total cost. Okay, so now that we have our constant of proportionality and we have our equation, the last part of the problem is to figure out how much it will cost to purchase 2 dozen cupcakes. How many cupcakes is 2 dozen? Yeah, it's 24. So if you haven't already, go ahead and finish the problem. I'll pause again just to make sure you've had an opportunity to work this one all the way out, and then we'll come back together and check. Okay, so using the equation with our constant of proportionality, which looks like this, we know that x is the number of cupcakes. So we are going to replace or substitute 24 in place of x because we want to find the cost for 2 dozen cupcakes, which is 24. So once you've simplified that and done your multiplication, you should get 60. So what does that 60 mean in the context of the problem? Right, it would cost $60 to purchase 2 dozen cupcakes. Excellent work. All right, folks, you did a great job today. Remember that we worked on how to use the constant of proportionality, which is k. Remember, y equals kx, where k is the constant of proportionality. Just a reminder, since that was the big thing we talked about, we figured out how to use that in order to solve problems and write equations. Guys, you really did a great job today. After the video, you will have some problems to practice on your own. I'm about to show you the independent practice problems now. You can also find them in the student practice for this lesson, which is posted on the website www.tn.gov/education. Okay, so here are those problems. I'll write the website for you here while you're looking at these. Good luck on this and do your best. There's the website in case you need to go there to find this practice. Looking at number 1 on this independent practice, folks, the question says, determine whether each equation represents a proportional relationship. If it does, identify the constant of proportionality. And just a reminder, as you're working through these, think about what that equation that we used all day today looks like when we're writing an equation using the constant of proportionality. Think about what that equation looked like to help you determine which of those are proportional relationships. And then think about where that constant of proportionality was located in our equation to help you identify the constant of proportionality there. All right, guys, I really had a great time today reviewing how to use the constant of proportionality to write equations and then using those equations to solve problems. Thank you for inviting me into your home today. I look forward to seeing you for our next Tennessee's at Home Learning Series lesson. Bye.